In the next one we're going to use the Pythagorean theorem. Whenever we have a right triangle and we want to find a missing side length like this one, and that's actually what we're doing here. It says find the missing side length of each triangle. But anyway, because each of these is a right triangle, we can use the Pythagorean theorem. So here's the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And then here's a couple of bits of information about the Pythagorean theorem. A tends to be the smallest value, and then c is the biggest value. Okay? And then for the sides of the triangle, the only one that really matters is c. C has to be across the hypotenuse. Okay? And it also has to be over here alone in the Pythagorean theorem. Now if you need to put a and b anywhere, let's just go ahead and put a here and then b here. Technically I could have swapped these, but the only one that matters is the red one. Okay? So let's go to, I'm going to solve 11 and 12 first, or actually 11 and 13 first, then 12. So again, that's C. That one has to be C. You always want to find C first, and then you can say, hey, that's A and B, because A is smaller than B. Okay? And then when you set up the equation, it looks like that. Then you have 6 times 6 is 36. 11 times 11 is 121. Okay. And then you get 157. And then somebody asked me a good question today. They said, hey, mister, how come you keep using the square root? Okay. You have to remember whenever we're solving for an equation, and you know what, actually, instead of C, I'm going to use X. Whenever we're solving for a variable or an equation, you want to get that variable by itself. So what I want is the x by itself. But right now we have x squared, and we need to use the inverse of the square to get rid of the square. In math, to get rid of something or to undo something, you always got to think, well, what's the inverse? Well, the inverse of square is square root. Okay? The square and the square root cancel. The x just falls out. And then what we're left with is the square root of 57, or 12.5. Let me just double check that. We have 12.5. Now, I'm putting both of these down because the final is going to be multiple choice. Every question is multiple choice. You may see this answer, or you may see this one. Okay? So there you go. So let's do 13. Again, 13, that's C. A is smaller than B. Okay? So if I write it, if I plug it into the Pythagorean theorem, it will look like this. 4 squared plus 6 squared equals x squared, because C is x. This is 16, that's 36. Add those two, you get 52. Again, at this point, you want to take the square root, because the square root and the square cancel. Then we just have our x. And the answer is the square root of 52, or 7.2. So you're going to have to look for one of these two. And this, I'm just typing that in the calculator to figure out it's 7.2. So here, I'll show you. See, there's the square root of 52. So that's 10, 11, 12, and 13. 12 is a little bit different, and it's only a little bit different because we know our C value for 12. See, for 11, I didn't know what C was, and for 13, I didn't know what C was. But for 12, we do know what C is. So then students are like, well, shoot, what is this, and what is this? Well, if I make it look like my triangle diagram, I'm going to say this is A and this is B. The only one that matters is this one. Okay, so let me go through and solve it. A, B, C. That's 100. That's 225. And then again, to get x, we want x by itself. So I'm going to subtract 100. That's 0. Then you have x squared equals 125. And then next we take the square root. Square root cancel. You're left with x equals the square root of 125. Or square root of 125, 11.2. Okay. Yeah, I was just double checking my work. And then 14 is kind of like 11, 12, and 13. Only they don't give us a diagram, but they tell us these are the two bigger sides. And what we want to find is the shortest side length. Okay? If these two are the two bigger side lengths, remember C is the biggest, B is the middle, and A is the smallest. So if I plug that into my Pythagorean theorem, it'll look like this. A squared plus B squared equals C squared. Okay? Now I'm going to save myself some time, and I'm not going to multiply this out just yet. But I know I need to get A squared by itself, so I'm going to actually subtract 28 squared. Bring down the equal sign, and that is 0. Then you have A squared, and this, I can type that in the calculator. That'll save me and you some writing. So I say 35 squared minus 28 squared is 441. And then we can be like, okay, well, what's next? I want A by itself, so I need to get rid of the square. How do I do that? We take the square root. And then this one, this is a whole number. The square root of 441 is 21. It's not a decimal number, so I don't need to write the square root of 441 here, because this is a whole number. All these other ones were decimals. They were decimal approximations. Okay. And then 15 is the same as 14. They tell us these are the bigger sides. C is the biggest, B is the medium one, and A is the shortest side, and A is what we're looking for. Okay, so it looks like this. A squared plus B squared equals C squared. Again, I'm not going to multiply these two out. I could if I wanted to, but I'm not going to. But I need to subtract 36 squared. That goes away, then you have A squared. And then again, this part is just 39 squared minus 36 squared. Is that 225? And then we're like, okay, what's next? Well, that we got to take the square root. A equals 15. Oh. Yeah, A equals 15. Two more.